Hey there, folks. So, last episode, we finished off by getting it set up that our AI NPC can now actually see the player character when they're looking at them. And you can see just in the top left there, it's actually just overlapping with the stat bar. We're getting a little on screen message, AI saw something, which is what we added. Let me just bring that up. We added that here to our on target detected. So, what we need to do now is actually expand on our TF character base type. So what we're going to do, the first thing we need to do is actually add a new data type in, and that's going to be for our creature type. So go into our C++ classes, project, public, and then we're just going to right click. And I need to fix that and move that to a different location. That's in the wrong place. So we're going to leave this option, right click, new C++ class, leave this as none. We've done this a few times in the past, but I'll repeat everything here. We're going to select our folder. We're going to select the data type folder. And we're just going to call this F creature type. F being the fact that this is going to, no, sorry, not F, E creature type. Sorry, E creature type. It's an enum, not a struct. And we're going to create that class. It's going to pop up here in Visual Studio, and we're going to get the message, do we want to reload? And we're not going to want to reload. We want to close the editor down when things start responding here. Okay, I'm going to move Visual Studio out of the way. So just to explain a little bit instead of just sitting here, what this data type we're adding, this new enum, is it's basically for us to be able to say, okay, this is a prey animal, a carnivore, a zombie NPC, a general human, and then you can have it so that the various different NPC types react to it in different ways. So okay, this is taking a little longer than expected. So what I'm going to do is I'm going to pause, wait for all of this to finish up, and as soon as we're saying that, it finishes up. So Visual Studio has popped up the reload all. I'm just going to wait for this to finish so that we can close down the editor. I want to get everything back in the right place. It annoys me when the content browser's in a weird spot and I can never find it. So either way, I'll pause the video here instead of wasting the limited video time waiting for this to finish, and I will be back once we are set up back in Visual Studio. Alright, so we are back in Visual Studio, and we're going to be doing pretty much the same thing we have done with our other data types. We're going to clear out the general information that gets added in by default, which is the constructor in the header. We're going to get rid of this and include E creature type .h, and we want to change that to generated .h. And then enum blueprint type enum class E creature type derived from uint8. And then what do we want to call this? So creature type, I'm just going to put in a few different options here. I'm going to put player because obviously that is the very first one. Actually, no, it's going to just be a general human. Creature type, small mammal, small animal, small carnivore, medium animal, medium carnivore. And you can probably get the idea of what I'm trying to achieve here. Sorry, I do have this issue of typing and talking. I have some trouble with that, so I'm just going to put a generic monster. So what this is for is basically this is going to say, okay, so this NPC or player character is a human, it's a small animal, it's a carnivore, it's a medium animal, it's a medium carnivore, large animal, large carnivore, or a, excuse me, monster. So, and the reason for this is, again, so you can have certain AI react to other AI in certain ways. Because obviously, if a deer sees, say, a bear, it's going to run away. If it sees a human, it's going to run away. If it sees another deer, doesn't really care. So, and then actually just quickly for the sake of ease within the editor, let's go through and add in some meta information. Oh, that did do that right. So, human, small herbivore, small carnivore, medium herbivore, medium carnivore, large herbivore. So where I'm thinking at with things like large, not larb, large herbivores would be things like cows, stuff like that. Cows, horses, non-prey, larger non-prey animals. So large carnivore, and then monstrous. So now that we've got this in there, we're going to want to add this to our characters. And because we want that for our player character and all NPCs, just like we did with our stimuli source, we want to add that to the TF character. Now in here, you notice we don't have any data types yet. So obviously we're going to need to include that. So include data type E creature type. So we're going to want to just copy this here. I'm going to want that to be a protected value, actually. So E creature type of creature. So we've got that in there now. By default, I'm going to say E creature type. Yeah, I'm just going to default it to human. Yeah, that's going to work there. Now, with that, what we're going to be doing here, where is our... There it is. We have our AI controller base, and get rid of you. Don't need you anymore. Don't need that open. Don't need that open. So I'm just cleaning up because I've got a lot of stuff in here that are no longer needed. So what we're going to want to do here is add in some logic. Sorry, I was just trying to think how to word this. Some logic on how to respond based on the particular target that was seen. In this case, because it's a site target. So what we're going to do is, we need to add that up here. We're missing an include. So include base class TF character. Because we need to be able to cast back to this to get that information. So if, ATF character pointer as TF char equals cast ATF character actor. If as TF character So what this does here is basically we're saying, okay, we know we've got an actor, but we want to check, is it a TF character? If it is a TF character, sorry, I completely missed something here. We need to add a function to be able to return this. So E creature type, U function, blueprint callable blueprint pure, E creature type. This doesn't need to be a pointer. Get creature type const, and I'm just going to add this into the header. Return creature type. Return type of creature. Oh, missed the tooltip. Type of creature for AI response. So we have now added in the function to get creature type. So we're going to go back to our AI controller base. We don't need to add an include for this because we added TF character and that is in our header. So I mentioned before, any includes are like a root structure because the AI controller is including the character while the character is including the creature type. We don't need to include it in the AI controller. So creature type is going to be target type equals as TF char get creature type. And this is where you would add logic in for, like, say, switch target type. And you would do that. Or something else you could do, which is actually what I'm going to do here, is going to create a function that is going to return an int. Now this is going to be dependent on how you want to do it. This return type of an int is I'm using to determine probably the best way to describe it is going to be a fear factor. It's like, okay, what is my response to this data type or its creature type? So int get response, get fear response. And we're going to pass in an E creature type, and we're going to leave that and create that definition. So what we're going to do here actually is go get fear response as TF char get creature type. Int response equals. So come on, IntelliSense, let me save. Okay, I'm going to just wait a moment there. So now there's a couple other things we want to do. So we've got onPossess, which already is populating a local variable. And this is one of the reasons I know I didn't really cover that on the episode where we initially created this, but it's part of the reason that we added that. It's a pointer. The memory usage is very minimal. It's not something I'm concerned about. So what we are going to do is in our get fear response, we are going to controlled pawn get creature type. Yep, that's exposed there because it's a child. So E creature actually no, we're going to do this. We're going to switch on that. Now this is something basically it's effectively a state machine or very close to, because you're going to have a switch within multiple switches within a bigger switch. So case E creature type human case E creature type monster, keep those at the top. Case E creature type small animal, case E creature type small carnivore, case E. You get the idea of what I'm doing here. So I'm just going to quickly type these out, and I will be back as soon as I've populated the rest of these. Okay, so now we've got these populated, and this is representing, okay, what is the AI I am using going to do? Sorry, I am possessing, not using. AI I am possessing. What is its, like, how is it seen? So with the human, we're going to go switch, and this is going to be switched off type, and that's the one that's coming in, and this is the enemy AI. So, or sorry, not the enemy AI. This is the visualized actor. Well, if a human, say, let's just go case E creature type human. If a human sees a human, okay, well now you need to think, is it a raider? Are they aggressive? Things like that. So you've got that option. You've got case E creature type monster. Okay, how are they going to handle it? What I'm going to do here is I'm going to populate this entire list with the cases, and I'm going to populate the additional ones as well, just because that's going to be a lot of typing, and it's the same typing. So I will be back in a moment once all that's populated. All right, so I've gone through and got that populated for each of these. You can see we're obviously switching on the type. We've got all of our cases, and I've just added a break statement at the end. It should never hit the break. Each of these should have a return, but it also is a nice fail-safe. And actually, saying all of this, I've actually thought of a much better way to do all of this. So, I'll finish off with what we've got here, because this is one way to do it. It gives you a lot more granular control. And actually, no, I'm going to stay this way. The other way doesn't give you as much granular control. So I will explain that, though, quickly. So what I was going to do is I was going to leverage the fact that that's 0, this is 1, 2, 3, 4, so on and so forth. You assign each of these just a integer value here within the declaration, and then what you could do is int start equals that. So what that would do, we've done that with our day length here. So we have 0, 1, 2, 3, 4, 6, 8, 10. If we were to use this here, we would just say we had min 300. This value would be 10. And then my thought there would be, okay, so it starts with a value of 10. We'll subtract the value of this, and then we can use that as our response value. But that does not leave you with much granular control. So we're going to continue on with this state machine mega switch statement. So if a human sees another human, I'm just going to return 0. That's an ignore it. If a human sees a monster, well, they're going to want to run away. I'm going to say minus, we're 8, so minus 4. And these are ranges you're going to want to predefine. If a human sees a small animal, it's going to be 0. Small carnivore, going to be 0. And so just to explain how these are working in my eyes, a negative value is run away. A positive value is chase after. So a human sees a medium, well, actually most of the, I'm going to do this quickly. So I'm going to pop that in. Large animal, we're not concerned about. A medium carnivore, I'm going to say, has like a -1. And a large carnivore is also going to be -4. Now, the reason for this is that's something that we're going to want to set as a Blackboard key for our behavior tree, because other evaluation is going to need to be done. It's going to be a case of, okay, we'll take the medium carnivore. It's like, okay, am I starving and need food? Like this -1 here, we're going to do some evaluation on that. And it's going to be a case of, this is a negative modifier for the ultimate end result of, is the target worth chasing? Is the target something I want to run away from? So what I'm going to do, again, just because there's a lot of repetitive typing here, all for the same thing, I'm going to go through and put in some base values for all of these here, and I will be back as soon as I'm done with that. All right, so I've gone through and got all those set up. Let me just expand these quickly and run through them just to give you an example, because I'll explain how I came to these numbers a little bit. So as I mentioned, this is going to be a overall reactionary equation. So if the ultimate value we have here is a positive number, it's like, okay, we want to go towards it. If it's a negative number, we want to go away from it. And the extent of that negative is going to be how desperate the AI is to, or sorry, the extent of that value, I should say, is how desperate the AI is to go towards or go away from. So we've got here human, sees another human. Fear response is non-existent. If it sees a monster, so that would be a hypothetical, because I don't know if they're going to be in the game, but, well, I'm going to be adding them, but it's not going to be a predominant thing in there. It's going to be one survival scenario. Say a zombie. Okay. Human sees a small animal, doesn't really care. We're talking things like mice, rabbits. A small carnivore, that would be, I can't think of something that would be that small that's a carnivore off the top of my head. I know they exist, but it would be something like that. Medium animal, we'll say we're looking at, say, a deer or a dog. For the carnivore, you'd be thinking a wolf. So again, humans see a deer, it's not afraid of it. Well, on average. There's some people who obviously are. They have a fear of deer. It's apparently a phobia, but either way. You see a medium carnivore, you see a wolf, you're going to be a little bit, oh, that's a wolf. You see something like a cow or a horse or an elephant. That would be another one, extra large animal. It's going to, you're not overly afraid of them generically. You see something like a bear, you're probably going to need new underwear, sort of thing. One thing I've missed here, actually, and I need to add this into all of them, is a default 0. Return. Actually, no, that will, I don't need to do that. That is going to get caught by that one there. So, anyway, so that is that one there. That's the human. For the monster, so if it sees a human, it's like, I want to chase after it. If it sees another monster, I'm not too worried about it. Sees a small animal, yeah, I could chase it. It's a little small. Medium animal, a little more. Large animal, so much, because a little more because it's bigger. Small animals, the same. I'm not going to individually run through all of these, but you could pause and see what sort of values I'm going for here. Small carnivore. Medium animal, medium carnivore, large animal, and the large carnivore. And ultimately, if you get to a point where you're adding in a new creature type and it's not part of this list, you're going to hit, well, ultimately, it's going to fall down to this point here. So as we've done already, logger get instance add message, error level, warning. And then this is unknown combination of creature type. So what we've done here, and I'm actually going to be wrapping the episode up because we're coming up close to 30 minutes here. So what we've done, and I know we haven't done anything in editor for this episode, but unfortunately there's just a little bit more we need to do to get this behavior response out of the way. So what we've done here now is when a target is detected, doesn't matter what that is, we're going to want to do some work with a stimulus actually, because it could be a sight, could be a hearing. But right now, if the target is a TF character, we're going to go through and get I'm going to actually call this fear response for the purpose, because we're going to have to do some additional mathematics here. Now, next episode, we're actually going to set it up so that the AI will run away. But that will be just really quick based off this fear response. And then from that, we're going to probably have 2, 3, maybe even 4 episodes. That's a lot of code work that's going to be covering the additional sort of behavior we're going to want to have here. So, but as always, folks, thank you for watching. If there's any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Try to respond whenever possible. If it's a little too complicated for a YouTube comment, feel free to hop into the Discord. I'm on there pretty much constantly. I have Discord running on my phone, so even if I'm at work, I can still get messages. I may have to tell you I'll respond later, depending on what the issue is. But anyways, folks, thanks again, and I will see you in the next episode. Hey there, folks. So last episode, we went through and got things set up so that our NPC would have a reactionary value, hit it instantly, based on the type of creature it sees. So in this case, we have our pawn, which is a human, and it didn't see anything because I believe... or did it? Either way, so we set this up so that our NPCs have a get fear response, which is going to be a plus minus value used to determine the reaction that the NPC has. And from that, we need to do a little bit more work and go through and set it up so that the NPC is actually going to run away. So what we're going to do, I'm just going to hop out of this, get rid of that breakpoint, hit continue, and you can see our NPC is, when this decides to actually work and not be laggy, is wandering around the scene. So the first thing I want to do is we need to add in a way to convert what is ultimately, actually I'm going to just change that to response value. We need a way to take this, what is now the response value, it was the fear response, and adjust that based on, or not adjust, but map that to a value to basically say ignore, attack, run away. Ultimately, that's the 3 final states that we need. So what we're going to want to do for that is we're actually going to want to create a new data type and another enum there. So I'm going to bring up the content browser. We're in our C++ classes project public folder. Right click new class. Leave this on none as always. Click the folder path icon there and select our data type folder, and this is going to be called reaction type. I'm going to create that class. I'm going to hop in. It's going to hop us back here to Visual Studio. And we don't need to do much with this one. So what I'm going to do here, I'm going to delete that there. From delete the functions within the source file, go back to our header and get rid of those. And I understand I'm doing all this while it's still debugging, so it's going to prompt me to reload. E-reaction type. So we want to add the include e-reaction type dot generated dot h, and then it's UEnum blueprint type enum class e-reaction type derived from uint 8. And this is going to be pretty simple. It's going to be rt underscore flee, rt underscore ignore, rt underscore attack. Meta. Actually, I'm going to grab that so I don't have to type it out again. All right, there we go. I'm going to say reload all. Do we want to stop debugging? Yes. Actually, turn off my speakers so I don't get into my system sounds. And because we saved it and everything, this reload's not an issue. All right. Now it's going to throw some errors. We're not worried about those because that happens all the time with IntelliSense. Grab that UMeta just quickly there. Close these two files. We don't need them. So we have flee, ignore, attack. So say this is a pretty simple pretty basic data type, I should say. And actually I'm going to grab this include here and get rid of these. So I'm going to add that include to our header, our source file for the controller base, because this is where we're going to be doing our function for that. I'm actually going to quickly fix this. Logger get instance add message error level error. All right, so I just wanted to add that in there. So for anyone wondering, just added in a log entry for no valid perception component, because obviously that's going to happen here. So first thing we're going to do though is we are going to create that function, and that can actually be a private function, and we don't need to have that exposed to blueprints. So enum get reaction type. It's going to take a const int reference. What do we call that? Response. Really? It does not like doing that? Oh, I'm an idiot. E-reaction type. Sorry, I didn't provide the data type. Constant reference. And just because every now and again while I make these silly mistakes, I do like to bring it up. These are the sort of things that programmers have happen to them all the time. It doesn't matter if they're a newbie who's been doing it for a month, or somebody like myself. I've been doing it for 10 plus years. I can't remember the exact math there. But the whole um, the whole thing with programming is you're going to make mistakes, and some of them are going to be really silly mistakes. Like right there, I completely spaced on adding in the actual data type it was meant to be returning. So, but with that, anyways, actually, this can be a const. So I need to add that in over here, const. What are you complaining about now? Nope, there we go. So we have a couple of different ways we can, let me save please, go about this. My approach to this is going to be, we have our controlled pawn. We have a pointer to that already. So what I want to do is I want to add thresholds to indicate how like afraid or how aggressive a creature is. So what we're going to do there, we're going to go into our NPC character header. We are going to add in a couple of variables here. So what I'm going to do, I'm going to copy this protected one. Int flee threshold equals, I'm going to say -4. Int attack threshold equals +4. Now we're also going to want to add some getter functions to be able to pull these out. So we're going to add in U function blueprint callable blueprint pure, and that's just so these are exposed to blueprints, even though I'm not sure if they're going to need to be. And it's going to be int get flee threshold const return flee threshold. And I'm putting this in the header just because it is such a simple function. Other classes can know about it. It's not going to add a huge amount of compilation time. And int get attack threshold const return attack threshold. All right, so now that we've got those, and go back to our AR controller, and go if response less than or equal to controlled pawn get flee. We are going to return E reaction type flee. If response greater than or equal to controlled pawn get attack threshold. Apparently I didn't have shift pressed. Return E reaction type attack. Otherwise, E reaction type ignore. So this is a very basic function, and the whole reason for this is ultimately, even though you may have very complex AI, you want to try and keep each of the individual components as simple as possible. So now that we've done that, well, we need a way to trigger all of this. So I believe that's the one we want here. So now that we've got this, though, I'm going to minimize get fear response, get reaction type. And just for clarity, the reason why right now this isn't, we're doing an int instead of passing just this through, is I do plan on adding things in like, okay, if it's extremely hungry and it's a carnivore, it's going to be more aggressive, things like that. So I want to try and pre-plan for that. So it's going to be, we've got an int declaration, and then we're going to add in, like, are we hurt? Are we hungry? Are we a naturally aggressive creature? Things like that. And they're all going to be plus minuses to this. You could, if you really wanted to, go like granular and go for a float for this, but an integer works fine, in my opinion, because it's naturally a keeps the number small in terms of a memory footprint in comparison. So a reaction type, reaction equal, if I could spell, reaction equals get reaction type from the response value it's because I can't spell response correctly. And then we want key. I believe this is what we want. No, sorry, we want to get the blackboard. No. We do want the blackboard, but that get blackboard asset set key. Okay, let's take a look at our random task we created, which I still need to move into a better location. Get blackboard component set value as. No, let's get blackboard asset. No, okay, what are we doing? Owner comp. Oh, it's behavior tree. Okay. I was in the right place. Blackboard component. Nope. Oh, how do I want to do this? Get behavior tree, blackboard asset. Okay. New blackboard data. Okay, and then what are our options here? No. Get blackboard asset. No. Oh, I don't have the blackboard component on here. That one. Okay, let's see. I think that's what we need. Because that gives us the component. And this is a lot of what you're going to end up doing as well. You're going to be bouncing back and forth, trying to figure out things, especially when it's code or an area of code you're not familiar with. So we want set. I want set key by name, set value. Is that the one? Yep. Set value, reaction state. Reaction type. Sorry, reaction. Think. That's going to complain because that's not right. Okay, how do we do that? You're expecting a T data class, F data type. Oh, I see, it's a templated function. Is that right? I think this is why I had in my notes set it as an int map, because it yeah, so this makes sense now. Why I had it as an int map, because moving this to the set value as int, so selected, what was that called? Get selected Blackboard key, that's it. Okay, so I'm going to actually change some of the stuff I've got here. Why are you not, what Blackboard, behavior tree, Blackboard component. Okay, where are you getting defined? So that is behavior tree tasks, BT task, Blackboard base. There we go. All right, so what I'm actually going to do here, we're going to go to our definition. We're going to try what I mentioned last episode about casting these to an int. So 0, 1, or 2. And actually, yeah, 0 fleet. 1 and 2. Yeah, we'll do that. 0, 1, or 2. And we'll go from there. So int reaction. Is that going to work? If I could spell. Why are you saying identifier gets selected? What? It's right there. No. Okay, so I guess we have to do this by name. So reaction value. Okay, so I'm going to get rid of that there. Let me save. Thank you. Okay, so we're going to try build here quickly. Now this, I can say it's very janky. Really IntelliSense. Let me save. Okay, so we're going to try build here quickly, and we're going to see if we can get this to correctly apply to our behavior tree. With that though, I'm going to pause the video here, and I'll be back once we're in the editor. All right, folks, so we did have a build error with our reaction type here because we used that forward declaration. Let's see, is that going to throw another error because we don't have it in the header, or is it just going to accept that? Just in case, I'm going to pre-prep, and we want that one there. Yeah, it's going to throw an error. So, all right, build cancel. We're going to cut this from there. And this is some of the things where, yeah, that works in some cases, but not in others. So let's add that in there, and that should do our build. So this go around, it should be pretty quick because it is just our AI controller base we're making changes to, which... What? What are you throwing an error about? Oh, no, there we go. All right, well, in the interest of time, I'm going to pause the recording, and we will be back once... Why is it building that? We'll be back once we're in the editor. All right, so we're back in the editor here. What I'm going to do is just open up the behavior tree for our NPC, and we're going to start work from there. And as always, it works on, opens up in the other monitor. So right now we have the sequence node, which is just going to do our go through, but what we want to do is add in a selector here. I believe it's selector, actually. Actually, first thing we need to do is actually our behavior Blackboard. We need to add in that key. New key. It is an integer. And we're going to go copy that out from what we put in there. That is the reaction value. And set that. So what we're going to do first and foremost is actually make sure that that works. So I'm going to hop back in here. We're going to throw a breakpoint where we get our reaction type, and then we're going to play an editor. All right, so yeah. Okay, so now that we've got that, hit continue. Actually, let's get reaction type response value. So a breakpoint there. Continue. We should see this again. Where'd you go? And it is being very laggy all of a sudden. So let's pause and find our NPC. I'm trying to remember how we pull up the AI data for that. No, that's not what I wanted. All right, give me 1 second here. I want to just figure out the best way to actually, don't want that selector. Blackboard. What do we set that to? We want that to be 1. Okay, yeah, sorry, no, I'm looking at my notes here and I've got this figured out. So, okay, so we want this is equal to 1. Reaction state. And we want to give that a default value, actually. Default key type int does not have a default value. Yeah, so by default we want it to be set to ignore. Now this is obviously just the early stages, because once this is set, there is not going to be anything to set it back. But so going back to our behavior tree, So yeah, now, sorry, I was looking at my notes. I was a little jumbled on this because my chicken scratch in my notes. But so what we want here is our selector. And the reason being for this is basically this is our default if we have nothing else to do. And what we want to do here is on result change, observer aborts self, because this is the lowest priority. What we want to have here is I'm just going to put some selectors in here and name them so we can. This is going to be our attack behavior. And this is going to be our flee behavior. So the way this is going to work is we are going to, actually this should these should be sequence nodes. So select that one, idle. Okay, we're just going to finish getting these set up, and then we'll end the episode. And next episode, we'll actually get the next phase of these. So this is going to be the attack, and this is going to be the flee. So we'll add these decorators in that we want. Add decorator, blackboard, select the decorator. We want to abort both for these two. Blackboard key reaction value is equal to, this is 2. Yeah, 2 is attack. Yeah, and 0 is flee. Okay. Add decorator, blackboard, select that. And 0. And this is, again, we want it to abort both itself and any lower. So what that'll do is it's going to, okay, if it's equal to 2, we're going to attack. If that changes, we're going to reevaluate. If it's equal to 0, we're going to flee. If it changes, we're going to reevaluate. And if it's equal to 1, well, we're going to just wander around. And if it's not, if that changes, we're going to stop and reevaluate. So with that, though, folks, what we are going to do here is end the episode. Next episode, we're going to set up the functions for our flee behavior, and that's going to be finding a point away from the target. And we are also going to then have, well, it's just going to be the move 2. And then, but at the end of that, once that move 2 is complete, we're going to reevaluate. And that's where this reaction value is going to change. So anyways, folks, thanks for watching. As always, if you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Thanks again, and I will see you in the next episode. Hey, folks. So last episode, we started setting up the overall reaction process for our AI. We got through to passing some information into the blackboard, and just opening that up, we've got that set as a blackboard key here, and in the behavior tree, let me open that up. In the behavior tree, we set up our basic process here to determine what its response was going to be. Now, what we want to do actually is we want to just test to see which one of these it's going to fall through to. Right now, because we're both human NPCs, it's going to return into the idle and ignore. So we're going to open up our blueprint. We are going to find our NPC here. And we want to change the NPC's type to one of the ones that's going to flee when it sees a human. So take a look at our code, get our fear response. 0, it's going to attack. So we know if we set it to a monster, small animal. So if we set it to a monster, it should attack us. If we set it to a small animal, it should run away. So with that, let's see if I can spell creature right. We are going to set it to a small herbivore. We're going to compile and save. I'm going to pull up our blueprint tree here, and let's see if I can get this where it's visible and we can run an editor, because it's really hard to do this when you only have one screen worth of... Why are you not letting me move? There we go. Okay, so it's going to be pretty hard to see. Let's move these around. But hopefully that gives us what we're looking for here. So you can see here, it's actually, this has failed. Reaction state, the idle state has failed. We are actually currently in the flee state, now, which is what we want. So if we hit stop there, we go back and we change this to a monstrous. We're going to compile and save that. And we hit play in editor and go back to our behavior tree. It hasn't seen us yet, so let's, there you go. And it should, we have no behavior to visibly execute. So let's get this fixed so we can actually look at that. So what I'm going to do here is quickly grab you, pull you over. Trying to organize these in a way that we can see which tree. It's all going to do the exact same thing right now, but I just want to like be able to visualize the way these are being executed. So let's clean that up. Here, move this over, bring it back down. We'll hit play. And there you go. So you can see it's a monstrous. It's seen us. It's moving to its pick and idle. All right. And we'll set that back to a small herbivore. Compile. Behavior tree run. Okay. Now we've got it's going into the flee state. And then obviously we've seen, if we stop that, set this back to a human because we know that's our ignore state. Run that again. Make sure it sees us. He's obviously seeing us at this point. So, and it's still in the idle state. So that is doing what we wanted it to do in the behavior tree. Now what we need it to do is to actually excuse me here. Sorry, I just had a cough there. Didn't want to deafen everyone. So what we need to do is actually start working on these functions here, because obviously we don't want it to just randomly search. So what we're going to do is we are going to create some new, we're going to create some new tasks here. So over in our content browser, go down to our C++ classes, public. Now, last episode, well, not last episode, the episode where we created the random point task, it brain's not working. I ended up putting it in the wrong folder. I wanted to put it into like an AI tasks folder. So that is the Blackboard base. So new C++ class, BT task, Blackboard base. I'm going to click next. What I'm going to do here is expand this. You can see we don't have anything in there. It completely didn't create it. So AI tasks is going to be the folder. Find flee point. So we're going to create that task. And then the other thing we're going to do is we're going to create another task, which is going to be the reevaluate. So Just while this compiles, I'm going to pause the video and we'll be back as soon as everything's good to go. Oh, I say that and there it is. It's good to go. So go into our AI tasks folder, create new class, BT task, Blackboard base, evaluate, and yes, reevaluate state. Reevaluate reaction state. Okay, we're going to create that class. I'm going to wait for all of this to finish, reload in Visual Studio, and we'll get working on some code. But for now, I'm going to pause the video, and I'll be back once this is all done. Alright, so we're back in the editor. I've closed down, back in Visual Studio. I've closed down the editor. I'm just going to clean up some of, no, I didn't want to do that because we're going to need that one. Find flee point, and it's missing a reaction one, but that's fine. Reevaluate reaction state. Okay, so get rid of TF character, TF NPC, and get rid of that one. All right, so what we're going to want to do here is, to start with, we're just going to copy some of the information we have in our random point and radius, because there's certain things we need to basically duplicate. The execute task, that is straight away one we need to do. Let's get this set up though. Private, protected, public. So we need our execute task, because that is the given. That's what happens when the function is called. And we need our I'm going to recreate this one and use a different naming convention. But actually, I think I said the way around. But either way, so we need our execute task. We need our constructor, which is, you can see that's where we set the node name. So find flee point. And what else do we have in there? Oh, that needs the F object initializer. And then we would want something like this, which is going to be our flee distance. So going to, no, I don't want to move things around. Grab that and set that in a private section. Float flee distance. We're going to set that to 5,000, just as a base value there. So let's create these. What I'm going to do between episodes, just because I realized I butchered my naming conventions here for what I want to do. Between episodes, I'm going to rename these, which is going to involve just recreating. What I'll do is I'm going to get everything into the correct folder, because my organization, the way I am, I want to have everything in the AI tasks and stuff like that. So it's easy when you're looking through your code, but don't need that open. So you can see here in a constructor, we just use the node name. So add that in quickly. Find flee point. And our actual functionality is going to be pretty similar here. We're going to be copying pretty much everything up to this point here. So what I'm going to do is I'm going to just copy this entire thing and throw that into our execute task node. We're obviously missing some includes, so grab those and throw those in. That should fix all of those. Yep. So right here, this is where things are going to change, because what we need to do is we need to find, well, where is the actor that we're running away from? So we don't actually have any place where that's stored. So what we're going to want to do here is in our controller base. Move you over. Try and organize these so they're in a better. Yeah. So in our controller base, we have right here, not on possess, sorry, on target detected. So what we're going to want to do is also set a value. So this get blackboard component set value as vector. Yeah, we still don't have access to that, so we're just going to put it target character, and it's going to be as tf char get actor location. And the reason why we're just doing this as a singular one is we can use the same value for attack. We can use the same value for brain's not working for the flee. So what we are going to do is in our find flee point, we can't use the get selected blackboard key because that is going to be our move to location. So what we're going to want to do is copy everything. Get return name key, get key raw data. Get value as, there we go. Get value as vector. And we want to use that same name that we just set. So target character. So we're going to go f vector flee point equals get that. So what that's going to do is it's going to grab that target character's location, and we're going to store that locally, obviously, because then we're not constantly having to call back to our blackboard there. And bear with me here. Pull some of the stuff up here because I can't remember if this is a C++ function. C++, look at rotation. Find look at rotation. I can't remember if there's a dedicated function for that or if it's one you have to Kismet Math Library. All right. So there we go. Oh, that's in the wrong class. That's in our random point in radius. So the reason we're wanting to use this is f rotator flee direction equals u Kismet Math Library find look at rotation. So the start is what are we calling this? NPC get actor. Actually, that's current lock. We've got that. Cur lock. flee point. So what this is doing is we are getting the NPC, we're getting the exact angle to look at it, and most fleeing is going to be done, for the purpose of this, 180 degrees in the opposite direction. So what we're going to also do then is flee direction dot pitch or roll. I can never remember which order these go in. Pitch, yaw, plus equals 180. So what that's doing, let me just pull up Paint here quickly. So we'll say we've got your player here, your NPC is here. The find look at rotation is going to find the angle this way. And then what adding 180 degrees to that is going to do is it's going to make it point this way. So, and that's the whole purpose for this, is like, oh, it's here, I want to run away from it. So actually I'm going to leave that, just minimize that for now. So next thing we want to do is sort of rotate the pawn. Now this obviously is not going to be the best way to do this. This is just a very quick setup to define how we want to get things moving there. So it's NPC set rotation, set actor rotation, and we're just going to put in flee direction. And what that's going to do is, again, going back to Paint, so we're going to say they're looking this way when they see the pawn, or see their whatever they're fleeing from. It's going to rotate them to face this direction. Now, the reason being for this is because how we're going to find our navigable point that we're moving to. So what we want here is another F vector target point equals NPC dot get, I'm sorry, it's not a dots pointer, get actor location forward vector times, what did we call that, flee distance. So if my math and my notes are correct, and I'm actually hoping, but what this is going to do is, again, going back to Paint, change to green now. No, that's not what I wanted to do. So that will basically, we're going to turn around and then we're going to find a point that is we're going to find a point that is X units forward, and then we're going to look around there. So this is where we're going to now go back to our random point in radius, and we have this. However, we're going to be changing some of these variables. So it is, instead of curlock, we're going to be passing in the target point. We're only going to give it a fixed search radius in this case. We're going to say 500, and we're going to pass that in. Actually, I'm going to move this down here to new lock. Okay, so now that we've got that, we can actually finish off with pretty much the exact same functionality there. We're going to copy that over, throw that in there, And this is where I was saying we can't use the get selected blackboard key because that's where we're going to be storing our move to location. So what we're going to do here, we're going to test this out. I'm personally actually this right here target point, I'm not 100% sure if that's actually going to achieve what I want, just because it's been a while since I've worked on this sort of logic. So I'm going to pause the video and I'll be back once we are back in the editor. Alright, so we're back in the editor here, and you can see I've got the behavior tree opened up. First thing we want to actually do though is in our Blackboard we need to create that new key we just started using. So it is a vector value and it's going to have a name of target character. And for things like this where case sensitivity and exact spelling are critical, I hate and personally never try to manually type it out. I'll actually come in here, copy it, and then back in the editor add in a new key. So now you could potentially store this as oh no, you can't. You've got it's an object reference. That's what it is. Yeah. Move the location or action value. Okay. So yeah, we've got that set. And then we're going to go back to our behavior tree here, and we're working on our flee case. So let's get rid of this. We're going to find flee point. Now we want to, Blackboard key is move to location. Flee distance is 5,000. We're going to save this. And then we're going to make sure we actually have our AI set to, what was it, the small animal. So creature type, small herbivore, compile and save. Bring this back down here, and we're going to hit play. Now hopefully I've got some breakpoints in Visual Studio set, so it should. There we go. Okay, so get rid of those. So step through that. So current location, we've got that. Flee point is going to be our target character. Yeah, that's what we want. Flee direction, we added 180 degrees to that, to the Z. So it should be running towards the bottom left corner in that general direction. Let's just make sure this executes and passes through. Okay, that does. So I'm going to get rid of this. I'm going to hit continue. It should bring us back to okay, well, he's moving in a weird way. Oh, yeah, the rotation is screwed up. But yeah, so and we're not reevaluating it. So it's constantly trying to flee from the point we had over there. So a couple of things we can do to fix this though and clean this up a little bit. So flee direction pitch equals 0, flee direction dot roll equals 0. So what we're doing here is we're trying to think, actually, could we do that just NPC rotation yeah, no, we'll just do that. So that should cover what we want there. So obviously we need to do some more for this. What we need to do is then call back and set sprinting. So what we're going to want to do, again, because he just walked off, in here, before we say we're done, we have currently the AI as an NPC and the AI as a the controller. So what we're going to want to do there is we're going to want to add in a callback to the controller that says set to flee. So that'll control our movement speed. And we can work with things from that. So what I'm going to do, though, because we're getting close to the end of this episode, I'm going to close out of the editor, recompile with those changes to the rotation, and we're going to see if that fixed that for us. So, So I'm going to just literally, now that we've made these changes, I'm going to do another build, and I'll be right back in the editor with these changes compiled. All right, so we are back in the editor with those changes made. So let's hit play. See, our rotation is good, so actually let's drop out because we're not actually seeing the behavior tree there. Okay, so bring that back. We'll hit play, bring this out just a bit so we can see which path it's going down. Okay, so it saw us and now it's running away. It's finding a point roughly over there. So, all right. So with that, folks, as I mentioned, this is where I'm going to end the episode for now. Next episode, we're actually going to start work on the reevaluate reaction, or reaction reevaluation, whatever you want to call it. But as I mentioned, between episodes, I'm actually going to go through and clean up the naming convention here and get this random point and radius actually in the correct folder because, well, that just annoys me. My organization is off there. So anyways, folks, as always, thank you for watching. If you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Thanks again, and I will see you on the next episode. Hey there, folks. So last episode, we set up the flee logic for our NPC over there. I can see him walking away into the distance. And in editing, I did point out that there were some fixes I wanted to make and some changes there over what I had originally done. So I want to kick off those this episode. But the first thing I want to do is I want to point out between last episode and this episode, I have actually updated to engine version 5.5. At this point, it is still in a preview state, so I would not recommend anyone else do this really. I only did this because I wanted to take a look at the changes in lighting and everything there, because that for me, well, there's actually a lot of changes in 5.5 that I'm interested in. So either way, what I want to do this episode is, when this responds after I said stop playing editor, that actually reminds me there is a bug that came up as a result of 5.5 that I wasn't seeing before. I'm just going to stop debugging. But so yeah, as I was mentioning, last episode we set up this flee logic here, and I want to clean a few things up. But also, as I just mentioned, we do have this error that's showing up right here that we need to fix. This is actually in our chrono manager, and the reason being is we're not correctly calling super end play. So in here, in our chrono manager, just as part of our end play, we do need to just pass through to the super end play, because that's a required component for things like garbage collection and stuff like that. And I've mentioned that in the past, and when we set this up, I missed adding that in. So when Visual Studio decides to actually work, if it decides to actually work, because I have noticed some weird oddities since I upgraded to 5.5, which is the other reason why I wouldn't recommend anyone else upgrade their project to using 5.5 yet. But I figured, well, I'm developer by profession. If there's some bugs and stuff, I can dig into it. So, all right, there we go. So we've got that fixed. Now, how did I want to change this flee logic? Let me actually bring this back down. We don't need that whole thing open. So right now, what we're doing in here is we're getting the NPC's location. We are changing their rotation, and then we're getting a distance further ahead from that. I want to change how we're doing that. So what I want to do here is change this to an F transform. And this is going to be curtrans for current transform equals NPC get transform. And the reason being for this is we're able to then modify all of this information, and we don't have to worry about things like set their rotation and things like that. So what we're going to do here is from this transform, we are then going to, as you can see, we've got a rotation directory. Look at rotation, we're going to do that. And instead of NPC set actor rotation, it's going to be curtrans, if I could spell that right, dot rotation, set rotation, and we're going to set that to the flee direction. And the reason being for that is we're not needing to, where did I put that in here? We're not needing to do this. And what do you, F rotator. I think that's just an IntelliSense quirk. No suitable use for F rotator. Okay, let's figure that out. Rotation. Dot. Can I do? Yeah, no. It's a rotator. And IntelliSense isn't working because I moved to 5.5. All right. So this is some of the things also I'll just quickly go over while I try to figure this out. Some of the things that can happen when you update your engine. Things like our Visual Studio integration plugin isn't updated for this. Curtrans dot. It's not a pointer. Let's have a look to see. Location. Actually, we want set component identity location set rotation. What inputs do you take? F quaternion new rotation. Okay. Let's have a look at this. Flee direction. Direction. And IntelliSense is being a royal pain because I dropped up. Well, it dropped up. I jumped up to 5.5. And you can see the IntelliSense is bouncing back and forth and back and forth on what it wants to, throws an error. Okay, that's working there. So then we wanted to go curtrans dot set rotation new rot. And we'll see if that works. Save that. Why is my system being so slow? Is Windows Defender running? Apparently there's something running on my system that is chewing up all of my system resources. I don't see why. Sitting at like 30% across the board, so something's happening here. So I'm going to pause the video quickly just because there is obviously something going on in my system. I'm going to figure out what that is, and I will be right back. All right, I'm not actually sure what was up with my system there. Maybe there was some background update going on, but I actually had to do a full system restart. With that, did lose a couple of things. However, nothing important, because I actually realized I was going down the wrong direction with the code anyways. So with that, where we left off is we were using this cur transform. So what we're going to do here is set our rotation. So cur trans, set rotation, flee direction, if I could spell flee correctly, dot quaternion, and that converts it over, which is quaternion. That converts it over so that it stops complaining. However, we need to actually make sure we can get rid of curlock. I missed fixing that here, so it's going to be cur trans dot location, so get location, get rid of you, and we don't need, with that we don't need this set actor rotation, because what that was doing is that was forcing our NPC to like turn on the spot instantly, which obviously wasn't the best thing to do. And then here we're going to be cur trans dot location, get location dot forward vector, and then flee distance. That multiplied by flee distances, that's how far away we're going to go. I do actually want to increase the radius from 500 to 1,000. And then from that, make sure new lock, target point equals, yep. So that fixes that up there. And this is basically, it stops the NPC turning on the spot. And it will allow any like animation blueprint you have, any turn radius requirements, things like that, to correctly go through and be applied there. So I'm just going to quickly launch the debugger for this one. Now, this may take a moment to build. This is the second time I've built with 5.5, so I'm not sure how quickly my system is going to build this one. So what I'm going to do is I'm going to pause the video, and I will be back once I have us in the engine, or if there's a build error, I'll obviously bring back to that. So, all right, so we are in the editor. It didn't actually take that long. I thought it might take a little longer than that to get in. What we're going to do, though, first, before we do our quick test, is I'm just going to hop back in and throw in a breakpoint I forgot to throw in. And we're going to hit play in editor. Now, this, again, may take a little bit to launch. Nope, there we go. So obviously it's instantly seen our character, so I want to make some changes there. So I'm going to just check though, follow through with this. Okay. Our target point. Not quite sure why it's got some really funky values there, but what I'm waiting for is it to, I'm just going to throw a breakpoint there. Okay, it dropped in. New lock, location. Okay, so it is moving there. Okay, so let's get rid of that and hit continue. And we're going to drop it a play in editor quickly. I don't want the NPC to instantly flee. Yes. Makes debugging things a little hard. So we're going to move that there, and then we're going to try play in editor. That breakpoint is still there. So let's run over. You can see we're behind the character, nothing. And then just as we run around here, there we go. So just quickly hopping back to the editor before we continue. It's not going to let me. It's going to let me move it out of the way. Yeah, you can see we've got approximately a 90-degree field of view. So bring that back in. Okay, so we know that is working based on that. We should see our NPC flee towards the wall off to our left. Where's my cursor? There it is. So hop back in. Yeah. So that is achieving pretty much what we want. The NPC is running over to our flee point. Now, as I had also mentioned last episode, we want to have a callback that is going to say run, because we want our NPC to actually sprint off there. So we're going to close out of the editor. Yes, I want to save that. That's just moving him around the corner. And we already have this here. So we have our controller. So what we are going to do is open up, I'm going to close out of these other functions. We don't need those, or other tasks, I should say. Going to open up our AI controller base, and I'm actually going to open up the header for that because we need to add a new function. We're going to add a public function, and this is going to be void set sprint. Set sprinting. Const bool reference b sprint. And this is just like everything else. Actually, sorry. We want to also make this a U function. Blueprint callable. And the whole reason for this is just like with everything else, it's constant bool for memory management. I understand Boolean. Again, incredibly small. It's good practice just to do that. We're going to create that definition. And then we have, where is our constructor? Controlled pawn, which is an NPC character. All we are going to be doing here is controlled pawn get stat line set. Oh no, control pawn. What? Oh, we don't have. It's right there. TF character. Or am I going crazy? Control pawn is NPC character. That's why we've got the wrong header there. So let's fix that, because up here we have TF character, which is what we want. But if we include NPC character, again, that also casts it down and includes TF character. So control pawn, use stat line component. Oh, that's what it is. Okay, let me undo this and see. Does that still throw the same error? Okay, we're missing the stat line header. Sorry, it's not included in the tree that we need. So what we're going to be doing here, include components statline component.h. There we go. Okay, so yeah, control pawn, get stat line, set sprinting, and we're just going to say b sprint. And that just, what we've done with this is, I'm sorry, I'm gesticulating with my hands. I do that a lot. I think I just smacked the mic, so I'll probably fix that in post if I did. What we're doing with this, as with everything else, we're trying to expose it in a way that our AI has the ability to make some of these changes. So now that we've got that in, all we are going to do here, because we already have that, we're going to be, where is it? That's here. We want to go con set sprinting true. And what this is going to do is it should have the NPC start running as soon as they see us. So I'm going to, just like last time, pause the build, pause the video, and I will be back once we are in the editor and we can test this out to make sure it's working. All right, so we are back in the editor. NPC is still around the corner, so let's try play an editor and see if this is working. So going to, yep, he's walking away from us, so we're going to run over and try to get seen. And then you can see they start running. Now, their sprint speed obviously isn't fast enough. We haven't set that up properly, but you could see there was a distinct change in their movement. So, all right. With that, though, folks, I know this is a little bit of a shorter episode. However, I have done some pre-planning for... Let me just bring back here. Actually, I'm going to close out of the editor. So we have our final component for this sort of whole flee state, which is our reevaluate the reaction state. I've done some pre-planning with this and made some notes, and this is actually going to be a little more involved because we do need to make some code changes in a few different places. And there's actually a bit of code involved here as well that is a little more complex. And I want to focus on all of that in one episode. So instead of splitting that between two. So with that, though, folks, as always, thank you for watching. If you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. As always, thank you for watching, and I will see you in the next episode. Hey there, folks. So last episode we did some cleanup and some minor refactoring for our find flee point for our AI. Let's wait for him to move. There you go. You can see he now actually runs. This episode I wanted to work on the reevaluate flee, because if you notice, we'll leave him just standing there, and you'll notice he's going to keep fleeing. And if I bring up our behavior tree that we created, come on. Thank you, content browser. You can see we're going into this flee state. Let's actually stop that and see if we can get this to debug live. Pull that over. We're going to play. So yeah, you can see we have currently, they are going through the idle state. And let's run over there and try and trigger the flee. You're going to turn around or you're going to walk off elsewhere? There you go. So we trigger the flee state. Apparently that was the best direction. But you can see they are stuck in the flee state. And that is because we are just doing this wait right here that isn't causing the actor to, or the NPC to reevaluate. So we're going to be working on that. So first of all, reevaluate reaction state. So what I want to do is I want to leave that wait in there. And then I want them to reevaluate. I'm going to take this wait down to, it's either going to be instant or 2 seconds. But so we have the reevaluate reaction state. And as you can see, we haven't added anything there. So it's just got that Blackboard based node name. And I do apologize if I sound a little off today. I am battling a cold. So hopefully it's not too bad in the audio for this episode. But either way, this is what we need to work on here. So I'm going to close out of this and the editor. I'd actually just launched the editor independently, so I'm not going to have any issues there. So with that, there is a couple of minor changes I want to make to some of the things I've done so far. The very first one is actually going to be this get value as vector for the target character. It's misleading. It also doesn't give us everything we need. So we're actually going to be changing that to an object.
which means we do need to make some changes here into our find flee point. Apparently my fingers are on the wrong key. Get actor location. Believe that's the right one there. I'm going to leave that for now. We'll change that in a moment. The other thing we need to do with that, though, is in our controller base, we actually need to set that. So this, actually, I can just copy most of this here. Again, my fingers are off place. I wonder what's set value as object. I'm just going to all right, and apparently IntelliSense doesn't want to work yet. So I'm going to pause the video quickly, just let IntelliSense catch up, and I will be back momentarily. I say that, I look over to pause the recording, look back, and IntelliSense is working. So quickly fix that typo there. So we have set value as object. So I'm going to actually just comment out this line of code here, and now that IntelliSense is working. Expression myself. It's a pointer, that's why I believe. Get actor location. What do we have exposed? Not letting me cast, so those. Okay, so doesn't let us use that default cast. Anyway, so we've just gone through here, and very basic. We've got the sorry, brain is not working with this cold. So we've gone through and we've just changed that over from being just a vector to an object. That's going to allow us to do some of the other work we need to do within this reaction state. But first and foremost, we need to set that up. So in our header here, we are going to copy over pretty much the exact same stuff we have done in our other ones. Find flee point. So you can see we have a flee distance and then the constructor and the execute task. So we are going to create our constructor and our execute task. Oh. Let's copy these because it's easier than typing it out by hand. Now with this, we don't actually need any variables that I am currently aware of to have, and that's things like we've got our flee distance that we've defined for the flee task, or we have our random point and radius, we have that search distance. So we don't need those for this, so I'm just going to now close out of these. We are going to create this definition, and it's probably not going to allow us to do this one. So create our constructor. Okay, so first of all, we're just going to give it its node name. UE8 reaction state. All right. So now with the execute task, we're going to need to get from the AI controller's perception component, we're going to need to get all actors. It's actually a function that's exposed through the perception component of get all actors, get currently perceived actors, sorry. And where you can find this, there's a couple of different places. We've got, obviously, the Unreal documentation. The other thing you can do is if you right-click on your declaration for the perception component and go to declaration. Now, this does take a moment because, or at least in my system, because IntelliSense is slow, but it should, ultimately open up the AI perception component header file, which you can also go to your include and just go to the document. It'll actually open that up pretty quick as well. So in here you have a ton of information exposed to you, and most people don't actually go about it this way. I found most people tend to go to the Unreal documentation, and don't get me wrong, this is useful, but a lot of it's pretty basic. So if we go in here and where's that function? Get currently perceived. So in here, just do a Control F, get currently. Well, it's not exposed. Okay, perceived. I obviously typed it wrong because it's right there. So here's that function. If sense to use is none, this is actually the exact information on the website. And the description information on the website is this little comment here. But what you can do is go to definition. Now, for anyone who doesn't understand C++ really well, this might not mean much to you, but you can go through here and, okay, what does this do? So we're saying the sense to use, we're taking in a parameter for the sense to use, and we're taking in an array of actors that we want to populate. So sense to use ID, if you don't pass one in, this is going to be null. Out actors reserve perception data, perceptual data.num. What this is doing is just saying, okay, this actor can see 12 actors. This NPC can see, or sense, I should say, not see, sense 12 other actors. We're going to say out actors cannot be any bigger than 12. We're going to predefine that number, and then it's going to iterate through all of those perceived actors, and it's going to say if it's perceived by the sense. If it is, we're going to push it into our out array. And that's what we want to use here, basically. And I understand this is a little different than my normal videos, but I wanted to try and explain how I go about doing things. So this is the function we're wanting. Now, with that, we need to pass in a sense, and we need to pass in the array we want populated. So back in our AI controller, what we are going to be doing here is a U function blueprint callable. Now, because we're passing in that array, we can't make this one a pure function, in my opinion. So it's going to be a T array of A actor pointers, get perceived actors. And I've spelled perceived wrong. Now, I will explain this as I go. So we're putting this on the AI controller because we don't want to expose our perception component. We want that to all be managed by the AI controller itself. So we need to create a function that is, well, it's not really a pass-through. So we're going to create this definition. I'm going to cut this. Oh, no. Sorry, my natural key selection is just off today because of my head cold. So TRA return.ret. As I've done in previous other ones, we're going to return ret. And what we're going to do here is, because in this case I don't want any perception, individual perception stimuli, like I don't want to differentiate between can I hear them, can I see them. It's just if there's actors, let me know. So what we're going to do here is perception component get currently. Why are you UA get currently perceived actors? There we go. We're going to leave this as null pointer, and we're going to pass in ret. And this is a very simple pass-through function. It's the pass-through function itself is creating the T array, we're populating it, and then we're passing back that T array. So now that we've got that, we can go back to our actual behavior tree task. So, well, we've got a lot of the code we're going to be using already defined in our find flee point. Well, not all of the code, but some of the code. So I'm going to go in here and, well, right here, this is the first thing we're going to want. We want to go if the AI controller is our controller base or can be cast to our controller base. So I'm going to grab that. And it's going to throw, obviously, the include issue, which is very easy to fix. All right. So in there, now that we've got that, we can just go TRA of A actor pointers. A actor pointers perceived equals con.get perceived actors. And then what we're going to do for const auto. Now, we actually don't need, no, because we already know they're A actors. We don't need to do the auto. So we're going to iterate through all of those. And the reason being is we know specifically that the NPC was fleeing a particular AI, or a particular thing, I should say. So what we're going to want to do from there is grab this actually. Grab this code out. So A actor pointer fled actor. U actor Blackboard component. So, anyway, sorry, I'm skipping all over the place, and I do apologize. Hopefully, this head cold's not lasting too long, because I understand this video is probably not going to be the best of quality, but I do want to try and continue working on the project, as I'm actually off work right now because of this head cold. So trying to record things as I go. I don't want to like skip things and have to go back and re-record. So, okay, so let's work through this back from the start. So we've got a list of all of the actors that are currently perceived. We have the actor we were fleeing from. And the other thing we're going to need here is a bool still flee. I'm going to set this to false. So what we're going to do here is for every actor we can perceive, we're going to say if, still flee equals to A is equal to fleed actor. If still flee, break. And this is just to save us reevaluating. So if we get an array of, let's say, 10 perceived actors. And the second actor in that array is the one we were fleeing from. We don't need to worry about the other 8 actors. We know we still need to flee, so that's what we're doing here. So basically we're saying is if this actor that was in the array returned is the one we ran away from, we're going to say still flee, and we're going to stop the continued evaluation. The next thing we need to do there then is actually set our... Is it in this one? Oh no, that's find fleet point. That's in our AI controller. Sorry. We have this value here. So what we are going to do, I'm going to put this back to... so I'm just going to copy that and I'll put this back to. So this, get Blackboard component. No, that's owner comp. Not this. Owner comp get Blackboard component set value as int reaction value. Now we don't have anything defined there. So what we're going to do is still flee. And if it's true, well, what was our flee state? That was... Oh, monkeys, I forgot. Data types. My brain is not working and it's been too long. Reaction type. Flee was 0. So we want to set it to 1 if it's not still flee, and 0 if it is. All right. Okay, now we've done that. It's just the normal finish off the reaction, the blueprint behavior tree task logic. So I'm just going to open up our find fleet point, and that's this one here, the finish latent task with the succeed or fail. So I'm going to say finish latent task with a succeed and finish latent task with a fail. And for anyone who may be skipping through episodes or isn't 100% sure, the reason why you want to include these finish latent tasks with, and then the succeed or fail is it's used by our behavior tree logic to dictate and decide which of the execution branches it needs to run down. So anyways, I'm going to do a build here, and I will be back either in the editor when we're ready to give this a test, or if there's a build error, I'll be back once that's thrown. Alright, so we're back in the editor, and everything seemed to build fine. We'll open up our behavior tree here a second, just take a look, make sure our node name has gone through. Yeah, you can see reevaluate reaction state there. So what I did, once the build completed, I just threw a quick breakpoint here on the execute task, so we can make sure to walk through and see what's going on there. So, where is our AI now? Where do you run off to? Oh, he's right there. Okay, let's... Oh, we have a bad code. Oh, that's our... I know exactly what that is. So that is, I failed to change the Blackboard data type. So we'll just launch back into the editor here. This hopefully won't take too long because it just built and launched. But yeah, so that is something you need to be aware of, especially when you're making changes to data types. And that's like here, we set it as an object instead of a vector. We didn't change it in the Blackboard. Minor things like that are going to, as you just see, cause exception, or just seen, caused an exception, and it caused the editor to bail. Because those are things, obviously, it's not intended to do. You're not meant to be setting a vector key as an object, things like that. So, and yeah, those, again, as I've mentioned, every time I do silly mistakes like this, those are things that come up every day as part of programming. It doesn't matter how good of a programmer you are, you're going to find little simple mistakes. So, open up our Blackboard here. You can open up. Yep, there we go. And you can see target character is still a vector. So we're going to select that. And we need to change this to a object. Save that, and we'll give this a try again and see if that fixes that crash we just got. And it's these sort of issues that you want to test your changes frequently as possible, because you're going to make, there we go, you can see he ran away. I forgot to reopen the behavior tree, but there we go, should hit our breakpoint. Okay, there we go. So let's take a look here. Perceived actors, we have one. And there's none, sorry, we have none in there. So this is why we set it to a default of false. So you can see it's false. Perceived actors is empty. So we're just going to straight through here, reaction to state, and we finish the task. So we hit continue. Now, obviously they're still running. We didn't fix that. So let's drop out of this quickly though, and I'll open up the behavior tree. And let's zoom this out a bit so we can actually see. We can't see the text, but that should be enough to see which path that's going down. Okay, so they're idling. We'll run through. It's going to hit that breakpoint. I'll just continue as soon as we hit it. Okay. Always running to that same point. I might have screwed something up there. I'm going to have to look into that. So we wait, we reevaluate, get rid of that breakpoint, hit continue. And you can see now they went back into their idle state. And then they're back into the flee state. So I may have an issue. I'm going to have to reevaluate that. But with that. But the other thing we're going to want to do here actually is, where did we set the on target detected? Where are we calling that? Get fair response, isn't it? No. Where are we calling that? I am drawing a blank. Find all references. Oh, find flee point. Okay, so we are doing it in there. We're all right. So all we have to do there is con set sprinting still flee. And what this is going to do is, if they're still set to run, obviously we're just saying, okay, keep sprinting. But if they're not, then it will drop back out. The other thing I want to do here, though, is find flee point. There is obviously something off with the way this is being done. Vector flee point, because it's meant to just turn and run away. That's what this is for. Flee direction equals, look at rotation. Okay, so that is get the current AI's location. Flee point. No, and it's still doing. Okay, now they're moving over to that corner constantly. Okay, let's try one more thing. I'm just going to move them out into the middle of the area. And we'll try this again just to see. So they're out there, they're walking. Okay, if this works, it should move towards the house. Nope, they are still getting. Okay, so let's change these values. I'm going to change that to 250 with a random radius of 50. Now, a lot of this is probably down to the fact I'm running in a pretty small area for comparison to what I'm thinking of here. I'm thinking of like out in the wild, you run into a deer in the forest. So I'm trying to approach that we can keep the desired direction in a particular way. So towards the house this time? Nope, they are still running to over there. Hmm. Okay, so there is obviously some flaw in my look at find look at rotation because here, yeah, you can see the find flee point failed and it ultimately ended up back down there. So there is clearly, I will openly admit I screwed something up here. There is clearly, I'm going to leave them in the middle there. There is something wrong in this logic here. So what I'm going to do between episodes is I'm going to sit there and I'm going to figure out just what I've messed up. And next episode will be fixing this because obviously there is something wrong here. So with that though, folks, as always, thank you for watching. If there's any comments, questions, concerns, suggestions, please feel free to leave them in the comments below or hop on the Discord. Thanks again, and I will see you in the next episode.